All right, so let's take a look at our next lesson here, Unit 6, Lesson 7, using similar triangles to solve equations. Now, what you're going to see is this is really similar to a lesson we did 2 or 3 lessons ago when we used similar figures to solve equations. So the ideas are the same, right? We're going to use these relationships that we know, all right, to solve problems involving linear relationships, systems of equations, and quadratic equations. And we are on page 47. And so once again, if two figures are similar, we know that their corresponding angles are congruent. All right, if two figures are similar, then we know corresponding sides are proportional. And just like what we did when we did similar figures, we're going to use these two relationships to set up the equations that we want to solve. And then we're going to figure out, okay, is it a linear, is it a systems problem, or is it a quadratic problem, and then use the appropriate tool to solve those. All right, this means that the ratios of all corresponding sides are equal. All right, so once again, if we know they're similar, we can say these things are true. And then we have to just know, okay, are we working with angles or are we working with sides? Because the equations and the relationships we set up differ between angles and sides in similar figures. All right, so let's jump down. All right, and let's just jump down to number 2 here. All right, and just because this picture is a little bit more complicated, right? And so I want to make sure that you guys are good with handling this type of picture. And notice we have a lot of lines here, all right? Okay, we have a lot of things labeled, so I want to make sure that you guys feel comfortable with translating all this information. Now, the biggest thing to start with is this piece of information right here. All right, triangle JGF, which is a small triangle right here, is similar to JLK, which is the big triangle. All right, so now we know all angles are congruent, or corresponding angles are congruent, and we know all corresponding sides are proportional. Now notice we know no information about angles here. All right, so we're dealing all with side lengths, all right, which means we need to set up ratios and solve. Now, what I want to show you is that what this is as meaning here, this type of notation, in case you're unfamiliar with this, means that this whole side is 88. So that means that JK is 88. All right, and then JF here is 4x plus 9. Now notice, and that's important because notice over here, when I look at this whole length, all right, is 48. So that means LJ is 48. But notice, if I wanted to know what JG would be here, I've got to do a little bit of math. Because this part right here is 30. Well, if this is 30 and the whole thing is 48, I'd have to do 48 minus 30 to figure out that JG would be 18. Now, in this particular problem, you didn't have to know that information to do it, but you will on some of them. So I wanted to make sure I reviewed that with you before we started the problem. Now, once again, the other piece is, notice that I can, in this picture, it's pretty easy to match corresponding sides. So it looks like GF corresponds to LK. But verify that with your similarity statement, right? So GF is right here, and LK is right here, so I can definitely see that those two sides correspond. So 30 to 80, all right, is my first ratio. Now notice in this case I want FJ here, which is 4x plus 9. Okay, and so 4x plus 9 to, now FJ would correspond to JK, this whole side, and this whole side is 88. And then you're starting to see a lot of the same types of problems now, right? Because every time we set up a proportion, we're going to cross multiply, right? And so we're going to have 80 times 4x plus 9 equals 30 times 88, which is 2640. And then when we distribute here, we get 320x plus 720 equals 2640. And then we can just continue, all right, with our solving process. All right, so 320x equals 1920. And I can divide by 320. And that tells me that x is 6. All right, now once again, if we go back and plug that in, right, we have 30 over 80 equals, and then 4 times 6 is 24. 24 plus 9 is 33, so I get that. And notice, divide this by 10, that's 3/8. Divide both of these by 11, that's also 3/8. So when I plug 6 back in, I can see that that ratio, all right, does work out. And we know that it has to work out because of the given information here that we started the problem with. Those two figures are similar, therefore the sides have to be proportional. All right, so let's go ahead and flip the page, and let's look at page 48. All right, and let's look at problem 3 here. All right, so notice now, we know that triangle hawk, or haw, is similar to triangle key, hawk. All right, so I think it's supposed to be hawk eye. I ran out of an E here. So there we go. All right, so there we go. Now notice the difference in this problem. We still know that the figures are similar, very important, but notice now we have angle information and not side information. So what that is telling me, all right, is that angles are, or the corresponding angles are congruent. Okay. Now once again, it looks like H and K correspond based on the picture, and I can verify that with my similarity statement up here. They do in fact correspond, and so I know that 6x plus 14y equals 44. Once again, from the picture, it looks like W and Y correspond, but I'm going to go up here and confirm it in my similarity statement. Yes, they correspond. So that tells me that we have 10x plus 18y is equal to 36. All right, so notice, now, we use the property of similar figures that corresponding angles are congruent to set up our equations. But now we have to interpret what kind of equations we have. So notice we have our x and y's mixed together here. So this is telling me that we have a system of equations problem. All right? And if we have a system of equations problem, all right, typically the easiest way to solve that is with elimination. All right? And that's what I'm going to do now. I'm going to eliminate our x's here. All right? So I'm going to look at 6 and 10, and I can see that the first number that is divisible by 6 and 10 is 30. All right, so I'm going to multiply this top equation right here by 5. All right, so 5 times 6x, that's 30x. 5 times 14 is 70y. And then 5 times 44 is 220, I believe. I'm going to just double check that here. That is 220. Now, we call this elimination because I want to eliminate. And the way you eliminate is that they have to be opposite coefficients. So since this is 30, I want this to be negative 30 here. So to do that, I need to multiply 10 by negative 3 to make that negative 30. So negative 3 times 10, there's the negative 30 I want. Negative 3 times 18, that's negative 54y. And then negative 3 times 36, I believe, is 118. So let me just double check that here. 36 times 3, 108, negative 108. All right. And then that's the elimination that we want, right? So I'm going to eliminate that guy. And then 78 plus negative 54, 70 minus 54 is 16y. And then 220 minus 108 is 112. And then we can divide 112 by 16. And I can see that y is equal to 7. Now, once I know what y is, I can go back to either one of my original equations. I can plug 7 in for y, and I can solve for x. I'm just going to do that with the first equation there. So 6x plus 14 times y, which we now know is 7, is equal to 44. All right, so 6x plus 98 is equal to 44. I believe, let me just double check, make sure my math is good. There we go. And then I can just keep going through that normal solving process here. All right. Okay, so negative 54, and we get x equals negative 9. All right, so there are our solutions. Now, once again, we should go back and verify it, right? So if these two angles correspond, they should be congruent, so which means if H is 44 degrees, K should also be 44 degrees. Now, don't freak out here because we do get a negative variable here, or a negative value for our variable. That's okay. It's as long as the angle itself is not negative. So don't assume just because the value you get is negative, that is going to make the problem not work. All right? So let's go back and just plug these in real quick right here. So 6 times x, which is negative 9, plus 14 times y, which is 7, that gives me 44. All right, so I can see that that worked there. Now, same thing here. This should match and be 36. So 10 times x, which is negative 9, plus 18 times y, which is 7, gives me 36. So I can see that the values, all right, that I solved for work, all right, and that is the example problems that I wanted to get through with you for this particular lesson. Just remember that there are some quadratics in here as well. I may not have done an example with you, but we've done a lot of those this year. So good luck on that. Do all your work, check your work on the answer key, and I will see you for our final lesson of this unit.